Alright, so we are still doing Honors Algebra 2 Pre-Calc, section 6.3 of Pre-Calc, which is vectors in a plane. So real quick before we walk into our next example, I want to talk about what the zero vector is. So the zero vector, right, so we already established that we could write, in the last video, that we could write vector v in component form as in these pointy brackets v1 comma v2, where v1 is the horizontal component and v2 is the vertical component, or like v1 is along the x-axis and v2 is up and down along the y-axis. Cool. So that's one way that we can write a vector in standard form, right? But there is the zero vector, looks like a zero, not an O, but a zero, that has 0, 0 as its components, right? So essentially what this is saying is this is a dot at the origin that doesn't go anywhere. It has no magnitude. It has no direction. This is the dot at the origin. So this is called the zero vector, right? So that's the zero vector. And it's worth noting that let's just say I have some vector w, right? The magnitude of vector w is equal to 0 if and only if, and I'm going to show you a cool notation for if and only if, sorry, brain shut down a little, if and only if. So there is actually a math notation for the phrase if and only if. It's IFF, if, right? So it's not, you don't read it like if, you just read if and only if. So if and only if, the w vector is the zero vector, right? So the only way that a magnitude has, or that a vector has a magnitude of 0 is if that vector happens to be the zero vector. So worth noting anyway, the zero vector, kind of a special vector, just like 0 is kind of a special number. All right, so what we're going to do in this example is I'm going to give you a vector in the notation of giving you, or in the form of giving you an initial point and a terminal point, and then we're going to find the component form of the vector. So in example 2, right, we're going to give the initial point, let's do point P is at the point -1, 4, cool, and we're going to say Q, well, when we'll say terminal point Q, right, so, and terminal point Q, and let's do Q at, let's do 3, comma 1. Sure, okay. So what we're going to do as our example is we're going to write, oh, sorry, I inched a little bit that way. So what we're going to do in our example is we're going to write PQ in component form. So if we were to move this to the origin in standard position, what would this look like? So let's talk about how we find that component form. Now, one option is to straight up just draw this, right? If you're somebody who's like, you know what, I'm just going to plot the points and figure it out, that's great and totally fine. But it's not the fastest option, right? So if we picture what's happening with a vector, right? If we want to write some vector v to be that PQ, right? If we want to write some vector v, essentially what's happening is, in order to find the horizontal component, we are subtracting, we take the final ending x position and we subtract the starting position. So what's going to happen is I'm essentially going to take my q1 minus my p1. So I'm going to take the 3 minus a -1. That's going to be my x component, my horizontal component. And I'm going to take my q2, which was the y of the terminal point, minus my p2, which was the y of the initial point. So I'm going to get a 1 minus a 4, right? And that's going to be my vertical component. So what's going to happen is I'm going to end up getting that this has component form 4, comma -3, right? Now, so that's great, and if you can do that, if you can say, hey, this is my answer, that's awesome, but if you need to see it, I'm going to show you what it would look like anyway. So if we were to write this, so I'm going to do a terrible job of graphing, because, you know, I'm me, so I always do. So -1, 1, 2, 3, 4, right, there's my P, that's where I'm starting, right, and then 1, 2, 3, 1, that's my Q, that's where I'm ending. So my vector looks like this. I start at P, I end at Q, that's my vector, right? And I can even call it vector V if I want, right? So the idea is that you can physically just count and figure out what's happening, right? So if you were to go from this start to end, you're going down 1, 2, 3 units, right? So notice that's why I get that -3 as the vertical component, right? -3. And to the right, 1, 2, 3, 4 components, or 4 units, which is why I get that +4, right, as my horizontal component. So you can actually figure that out by just actually drawing it, right? Now, if I were to draw this vector in standard position, right, in standard position, it would have the same magnitude, the same direction, but if I draw this guy in standard position, sorry, the computer frequently falls asleep, I must be really boring. If I were to draw this in standard position, and again, apologizing profusely for my lack of graphing, instead of point P being here, point P would be at the origin, because that's what it means to be in standard position, and I would still go down 3 units, and I would still go right the 4 units, and there is my vector v in standard position. They're the same vector, just in a different spot, right? So it's like you physically took this vector and said, hey, you're not in standard position, you're in standard position, and that's the idea. But again, the short way to get component form is that the horizontal component is really just the x-coordinates, so you do the ending x minus the starting x. And the vertical component is really just the difference between the y's, so you do the ending y minus the starting y. That's the gist of how it works.